Okay, 6.1 and 6.2 is over exponential. So let's first talk about what is an exponential. An exponential is going to be of the form y equals a to the x. The thing that's different about what we've been talking about in the past is the exponent is the thing that's changing. So we've been looking at stuff like x squared. The exponent always stayed as a 2. Now we're going to look at stuff like this, 2 to the x. The exponent's going to be changing. So what ends up happening is these things grow a lot faster. Okay, so let's first talk about our exponent properties. These are really important, and these are things you have probably already talked about, but I want to go over them again because they're really important in this chapter. Exponent properties, talking about combining exponents. If you have, say, something like this, it can be written as a to the x plus y. If you have this, I'm just going to go through and write all these and explain if I feel like it needs to be explained. On this one, it only can be distributed to each of those pieces individually if they are multiplied together, not added together. And we can extend that to division as well. If you have a negative exponent, it can be written as a positive exponent in the bottom part. If you have a fraction, it can be flipping the fraction with a positive exponent. Okay, one rule here that a lot of people forget about is if you have the nth root of x, it's the same thing as x to the 1 over n. And so, similarly, if we have, say, x to the a over b, that can be written two different ways. You could say the bth root of x to a, or the bth root of x all to the a power. And then if a to the x equals a to the y, then we can say that x equals y. And the last rule is a to the 0 power is 1, such that a does not equal 0. Anything to 0 power is 1 except 0 to 0 power. There's all of our properties. Okay, so if you go and graph these things, let's say you go on your calculator. I'm going to assume you can look it up on your or graph this on your calculator. It is going to look like that. Now, if you do, say, f of 0, that's 2 to the 0 power, which is 1. So right here, every exponential is going to cross at 1. So if I do like f of 2, you get 2 to the 2 power, which is 4. F of 5, 2 to the 5th power equals 32. So it's growing really fast. But over here on this side, let's look at this side. Okay, so if I go on a negative, say I have f of negative 1. That is 2 to the negative 1 power, which one of our rules says it would be 1 over 2 to the first power, or 1/2. Let's go a little bigger. Let's say f of negative 8. No, let's not go that big yet. Let's go f of negative 4. 2 to the negative 4 power, 1 over 2 to the 4th power, 1 over 16. It's a smaller fraction. If we keep going, if we go to something real big, like say f of negative 10, that's going to be 2 to the negative 10th power, or 1 over 2 to the 10th, which is 1 over 1024. It's just a really, really small fraction, but it's never going to be 0. So it tells me it's never going to equal 0 on the left-hand side of that. It just keeps going, kind of tapers off, limits out at 0, if you will. So we can say that the domain is going to be from negative infinity to positive infinity, but the range, it does have a specific range. It's from 0 to infinity, and I put a parenthesis on 0 because it can never equal 0. We don't want to put a bracket there. It's going to limit out at 0. Okay? Another number that we're going to use in this chapter is e. E is kind of like pi. It's one of those numbers that it shows up in nature, and so mathematicians have given it a name. And so E is approximately 2.71828, and it keeps going and going and going. There is a button on the calculator for E, and so we're going to use it. This is not some magical, mystical thing. It's just like pi. It just shows up in any kind of growth model, and we're going to use it sometimes in these exponential problems. On your calculator, if you have a TI-84, if you look on the right-hand side, left-hand side, there is an E button. It's right, if you go to the button right beside 4, it says ln, and it is the second function of that ln button. And it says e to the x. If you push that, it'll give you the option to raise e to a power. If you look over on the right-hand side, the second function of the division button is just e by itself, if you just want e by itself. But most of the time we'll be raising it to a power, so we're going to use that second function of ln. So let's talk about solving some problems here. Let's use our rules to solve some of these. Now there's going to be a lot easier ways to solve these, but right now let's just use the properties that we know. So first here, I can take this, and I want to write it as the same power because I want to use rule number 10, I think it was. Yeah, we're going to use rule number 10 to solve some of these. So if I can write these as the same power, I can make the exponents equal each other. So I can say that 3 to the negative x is the same thing as that. But then 81 can be 3 to the 4th power. And that's just something that you kind of have to be good at arithmetic to recognize. But you can play with it on the calculator and get that. But at this point, you can say negative x equals 4 or x equals negative 4. Okay, another problem, say I have 2 to the x plus 4 power and 8 to the x minus 6. You can see I can take that 8 and make it 2 to the 3rd power. And I can combine those exponents by multiplying them. Then use rule number 10, or property number 10, and simplify from there. Let's see here, I get negative 2x plus 4 equals negative 18, or negative 2x equals negative 22, or x equals 11. Last little example here, let's say I have x to the 4/3 power equals 81. You use a couple different rules here. You can do it 2 different ways if you want to. Let's say I use the one that says I go the 3rd root of x to the 4th power equals 81. And then you can undo the 4th root by 4th rooting it, and if you take the 4th root of 81, you get plus or minus 3. It's always good to remember that when you take even roots, it's plus or minus. And then you can cube both sides to get rid of that, and you get 27 and negative 27. 2 different answers there. Okay, so let's talk about some applications of exponentials, and that's going to be like bank accounts, compound interest. Like a bank account, it figures your interest based on an exponential model. And the formula we're going to use is A equals P times 1 plus R over M to the MT power, where P is principal. That's how much money you put in. R is interest rate. It's going to be a percentage. M is number of compounds per year. And T is years. Okay, so let's say I'm given a problem. You put $1,000 at 4% compounded monthly for 10 years. If we plug everything in, we get principal is $1,000 plus 1 plus 0.04 compounded monthly is going to be 12 to the power of 12 times 10. Now, when we put this in the calculator, it can be tricky. I'm going to write it out how you would put it into the calculator for it to work correctly. You got to put parentheses around those exponents. If you do it like that, you get $1,490.83. Okay? So let's say, how much do we invest to get $6,000 after 5 years compounded weekly at 3%. So my ending amount is going to be 6,000. I don't know my principal. 0.03 compounded weekly is going to be 52 to the power of 52 times 5. So if I want to solve for P is 6,000 divided by 1 plus 0.03 over 52 to the power of 52 times 5. And if you do that, you get $5,164.47. Now we have another formula, and that's for whenever you start compounding more and more and more, it gets to the point where it's almost compounded continuously. We have a formula for continuous interest, and that uses my little e. Okay, again, e is just a number. It's just between 2 and 3. So let's say I have $5,000 compounded continuously at 10% for 30 years. Okay, longer amount of time, higher interest rate, compounded continuously, we're going to end up with quite a bit of money. If we put that in, we get $5,000 times e to the 0.10 times 30. Make sure to put parentheses around that. Let's see here. I got my calculator. Let's see what I get. Make sure to use the E button on the calculator and you get 0.10 times 30, and you get about $100,427.68. Okay, so quite a bit more money. The reason was because we compounded more often, it was for a long amount of time, and it was a pretty high interest rate. So that's just kind of how compound interest works. We're going to stop there.